So you'll notice in this question we've been given the mass of both ammonium chloride and also of calcium oxide. So we know that we've got 200 grams of ammonium chloride and we've got 50 grams of calcium oxide. So the first thing we need to decide is how much, which reagent is in excess, and to determine that we have to work out the moles of each one. So let's work out the moles of ammonium chloride first of all. That is going to be the mass, which is 200 grams, divided by the molar mass, which is 53.5, and that equals 3.74 moles. Now let's work out the moles of calcium oxide. So that's going to equal the mass, which is 50, divided by the molar mass of calcium oxide, which is 56.1. So let's do that. And that comes to 0.891 moles. So to decide which one is in excess, we need to look at the mole ratio, because we've got 2 ammonium chlorides for every 1 calcium oxide. So if I've got 3.74 moles of ammonium chloride, the number of moles of calcium oxide that I require to react to that is going to be 3.74 divided by 2. And that comes to 1.87 moles. So you can see I've only actually got 0.891 moles of that. So I haven't got enough moles of calcium oxide to react with all of that ammonium chloride, and therefore ammonium chloride is in excess. So let's put brackets around that, because we're not going to use that value anymore, because to work out the amount of ammonia I'm going to make, I need to use this number, because I've got too much of ammonium chloride. So here's the equation again, and as I say, we're going to use the moles of calcium oxide. So for every 1 calcium oxide I make 1 ammonia, so the moles of ammonia is going to equal the same as that of calcium oxide. So that's 0.891 moles, and therefore to find the mass of ammonia, I'm just going to times that number by the molar mass, so 0.891 times by 17, and that gives you 15.1 grams. Right, so here's another example, but this time I have got 1,000 grams of nitrogen and I have got 500 grams of hydrogen. So again, I need to work out which one is in excess to be able to use it. And to do that, I need to work out moles. So first of all, moles of nitrogen is going to equal 1,000 divided by 17, and moles of hydrogen is going to equal 500 divided by 2. So if we run those calculations through, 1,000 divided by 17 comes to 58.8 moles, and 500 divided by 2 comes to 250 moles. Now when we come to look at the mole ratio, we see for every 1 nitrogen I need 3 hydrogens. So to react with 58.8 moles of nitrogen, I would need 58.8 times by 3. I would need 176.4 moles of hydrogen. However, you can see I've actually got 250 moles of hydrogen, and therefore I can say that hydrogen is in excess. I've got too much of it. Right, so now we know that we can ignore the hydrogen. If I've got 58.8 moles of nitrogen, I'm going to make double the number of moles of ammonia. So moles of ammonia is going to equal 58.8 times by 2. And that equals 117.6 moles. And therefore the final part is to work out your mass of ammonia, which is going to equal your moles times your molar mass, which is 17, and that comes to 1999 grams, which rounded up to three significant figures is going to be 2000 grams.